And today, we're going to discuss this phenomenon. We will discuss it from several viewpoints, from the standpoint of science, from the standpoint of clinic and laboratory. And after that, we will sum up the results, where we are and where we're going. Good morning, colleagues. It's my pleasure to introduce our first speaker, Alexey Viktorovich Tutelyan, and we will speak on the following subject: antimicrobial resistance, scientific and practical development of this problem. Could you please switch on my slides? Next slide, please. Unfortunately, we do not have clickers here, so I will have to tell you when to switch the slides. And I would like to speak about contaminant conditions. And you see that WHO General Secretary in 2019 said that all countries should find a balance between the access to the essential antibiotics and prevention of antimicrobial resistance. According to CDC, every year about 50 million courses of antibiotics are introduced in the USA in cases when it's not really necessary, and you understand that in other countries it is no better. Next slide, please. In the Russian Federation, antimicrobial resistance monitoring is on. This system is quite efficient. These are laboratory service in medical institutions, epidemiological departments of Russian Watchdog for Consumer Protection in Russian regions, monitoring of isolates from environmental sites. From food. It also includes veterinary monitoring of microorganisms. And of course, research is conducted by various institutions, all types of institutions. Now, I would like to develop on the system of monitoring over antimicrobial resistance of the Russian Watchdog for Consumer Protection. We have two reference centers. They are based in the Central Research Institute of Epidemiology of Russian Watchdog for Consumer Protection, and they are engaged in preventing resistance to antibiotics in food industry and in medical institutions. This is a very important area indeed. So it's like a hidden part of the iceberg that actually shows why this problem is so important. So this is the information taken from Reference Center on Food Products, and here you can see the sources of microorganisms with antimicrobial resistance. You can see that we have had similar situation over the last 3 years. First of all, these are poultry products and meat. So you see that in 2020, half of such agents were found in poultry products. The structure of resistant microorganisms detected in food products. So actually over the last 3 years, the structure hasn't changed. Salmonella is in the first place. It is followed by Staphylococcus aureus. And last year, Staphylococcus aureus decreased a bit. However, the stereo monocytogenes grew significantly. These are the data on medical institutions. These are the data of reference center. They show the structure of resistant flora. And they show that actually this structure is preserved. The dominant role is played by escape pathogens. And speaking about resistant strains, here you can see the distribution of them. 51.5% is ESBL, and MDR is also quite disseminated. 1/4 of the strains had multi-drug resistance. It shows that the problem of resistant strains dissemination is really important. What can we do about it? Well, of course, we will try to develop new antimicrobial drugs, but you can see that it's quite difficult to do it. "222 drugs are being developed in the world. This work is in process, and their efficiency and safety should be proven. According to optimistic scenario, by 2030, 2 or 3 of these drugs will be registered. So the academic community decided to look for various substances that could influence resistance. You know that there is internal or natural resistance. And all of us are well aware of acquired resistance. These are resistance genes. And actually everyone can detect it. And there is also adaptive resistance or transit resistance, tolerogenic resistance. There are a lot of names for it, and this is one and the same phenomenon. It shows that this phenomenon hasn't been well studied yet. And we have a lot of work ahead of us in this area. This is the transit resistance. It has been known for many dozens of years. You know that this experiment was conducted more than 120 years ago. This is a sample of water. So it is taken, and under the microscope you can see a lot of microorganisms. And nothing grows in battery plate. These are bacteria that cannot be cultivated. And they are the carriers of this transitory resistance. These tolerant or persister cells, you can see them in the middle, they have a unique capacity to be transformed into active vegetative forms, or they can also be transformed into antibiotic forms that can exist for millions of years in soil. These are VBNC cells. And what molecular stimuli can initiate them? Actually, it will determine the way they will develop. The control of this non-cultivated form generation has been well studied. You can see that there are a lot of various substances. that can regulate this adaptive resistance of microorganisms. In particular, we're engaged in studying oxaloxybenzols, and this is our reference center. Actually, it is involved in this work, and we have found that when we add such a substance, in particular hexylresencinol, but that's not actually important, there are dozens of them and hundreds of them. This is just something that we started because it was registered. It was registered as a medicinal product. So the antibiotic was registered as a medicinal product, and this substance was registered as well. So here there are 2 registered substances, and in principle it's more convenient for practical use compared with the situation when one of them were not registered. When it is added to strains, for example isolates of gram-positive bacteria, these are Staphylococcus aureus, for example, and I'd like to stress that minimum inhibiting concentration of antibiotics, actually when this hexylresorcin is added, this concentration is decreased by 128 times. It means that antibiotics can be used in a lower concentration. Speaking about gram-negative microorganisms, that is the same. So, when we use ciprofloxacin, we see that Pseudomonas aeruginosa minimum concentration is 50 times decreased. These are in vitro data. So the speed of Klebsiella death grows as well when we use polymyxin, and you can see clear dose-dependent death when polymyxin is used. And when we add polymyxin to the minimum concentration, when we add hexylresoxin to it, then Klepsiel pneumonia death is sped up several times. After that, we started in vivo trial on mice. This is Mycobacteria smygmatis. And you can see that when we use isoniazid and hexylresorcinol, the number of CFU in mice spleen significantly decreases. These are the data on the sepsis in white mice, polymyxin plus hexylresorcin. So, on the 5th day of observation, actually all of them died, but when polymyxin was used together with hexylresorcin, then on day 13 and on day 12, all the animals were alive. It shows that this area is quite promising. And it actually means that we need to study the genes that mediate adaptive resistance or transitory resistance, because it is also genetically mediated. These genes should be studied. We need to develop test systems. And just like resistance genes, we should determine tolerance genes. And in conclusion, I would like to say the following. Test systems that determine adaptation are important for us to develop, and also we need correction of antimicrobial therapy and prevention, taking into account persistent forms, and we also need to search and try combinations of antibiotics that allow us to overcome the resistance that had already been generated. This is also an important area for research. So there is so-called adjuvant antimicrobial therapy, and actually it's quite similar to adjuvant chemotherapy. And also, we need development of new forms of antimicrobial substances. These are binary drugs that I already described. Thank you. Thank you, Alexey Viktorovich. And in a few words, I would like to emphasize that in this presentation, you introduced the first results of our pilot project conducted by Russian Watchdog for Consumer Protection today, and I think that this is the first attempt to systemically analyze and control healthcare-associated infections and their agents. Thanks a lot, Tatiana. So, the next presentation will be conducted via Skype, as I understand. Professor Elizabeth Taylor will speak. So, can we connect here now? Okay.
Colleagues, and I'm delighted to be here and apologise that my colleague, Dr. Getahun, who is the head of the Global Secretariat, has been booked an urgent meeting, so I will give the presentation on his behalf. If I could have my first slide. If there is a problem with this, I can present my own slides. Whichever the conference organisers would prefer.
Коллеги, слайды будут у нас?
Colleagues, are we able to show the slides?
Colleagues, could I have an indicator from the conference organisers whether you would like me to present my own slides?
Elizabeth,
yes.
Please run slides on your computer.
You would like me to share my... Okay, that's fine. So, colleagues, as I say, I'm delighted on behalf of WHO and the tripartite to talk about the One Health and global response to antimicrobial prevention. Antimicrobial resistance is a global threat and one of the most pressing threats, not only developments of 20th century medicine, such as cancer treatments, invasive surgery, and anything that requires suppression or medical care. It is also a major threat in the developing world and emerging nations, which still have a major burden of infection. And it is these countries with the least resilient health systems where the burden will be greater. We are already seeing the threats and dangers of resistance through tuberculosis, through untreatable neonatal sepsis, but it is very often silenced, a problem that goes undetected because in most of the world, capacity to identify resistant infections is very weak. We talk a lot about the future risks of resistance.
Мы часто говорим о будущих рисках резистентности. Здесь вы видите данные, согласно
but high, and particularly again in low and middle income countries. There may be biases in this data, but it is a very real and current problem across the world. And for this reason, this is something that is being addressed not only through the health system, but has to be seen as a part of the sustainable development agenda. It is a problem that is emerging from the abuse of antimicrobials, not only in the human sector, but in animals, in food production, and through pollution of the environment. And it is by working through these sectors across in partnership sectors that we will make progress. And if we make progress on other elements of the Sustainable Development Goals, on improving water and sanitation supply, and developing sustainable production of food and antimicrobials, that will also make huge progress towards the control of antimicrobial resistance. We are delighted that there is now a specific indicator on AMR within the Sustainable Development Goals, and we are asking all countries to track the proportion of patients with bloodstream infections due to selective microbial contamination. And how have we got into this problem? And it really is that antimicrobials across the world have very often been used as a substitute for good care, good hygiene. These pictures are from where I've been working in Africa, but the problem is the same in the United Kingdom, where I come from, and across the world, that we don't pay enough attention to infection prevention and control. Physicians, particularly when busy, will provide antibiotics or prescribe antibiotics as a way of satisfying the patient and dealing with them quickly, without perhaps exploring, making a proper diagnosis and a better care pathway. And of course, in many parts of the world, antimicrobials are available over the counter or over the market store with no professional support at all. And this is a problem in the human health sector, but it's also a problem in animal health, where there is a big desire to intensify agriculture. There's a huge demand for cheap meat, and we have found that we can keep animals in overcrowded and insanitary conditions if we use large amounts of prophylactic antibiotics. The problem is also compounded by the fact that small amounts of antibiotics result in growth promotion, and so they are very often routinely used and added to the food of animals to support growth. This is something that many countries are banning now, and we are very keen should be phased out as quickly as possible. Because obviously subtherapeutic doses can create huge problems. But the problems of resistance also occur in the environment. The evidence base of the importance of antimicrobials in the environment is growing, but we know that whether it is from waste from pharmaceutical manufacture or from effluent from either feces of animals or the urine of animals or from hospital waste, a large amount of antimicrobial residue gets into the environment, into soil and wastewater. And there are obviously resistant organisms from feces, from contamination, forever, also there. So the risk of the development and transmission of resistant strains in the environment is also very important. So the need to strengthen our sanitary pollution control is also fundamental. And the need for us to work with colleagues in the environment, in the UN Environment Programme, is also extremely important. Now, the rising tide of resistance would be a problem enough were it not for the fact that the antibiotic pipeline is also almost dry. As has been said, developing antibiotics is difficult. There was a golden age in the 1930s and about 1980, where, as can be seen from the slide, a large number of the major classes of antibiotics were developed, and we felt we had access to cheap, effective drugs, and this was very easy. And that really has stopped since the 1980s. Partly because it's much more difficult. We don't seem to be able to find, the science is harder to find new antimicrobial agents that are effective. And also because of market failure, because pharmaceutical companies can make more profit through drugs for non-communicable diseases that people will take for a lifetime. So we have a major crisis, really, as has been said, with very few new drugs in production, and most of the ones that are being developed are not truly novel. We have a list of priority pathogens that WHO provides to try and shape that research agenda. There is work done to try and stimulate it, but it is nevertheless might face a very dry pipeline of new products. So it is all estimated, and this data comes before COVID, and COVID has very much taught us just how big the impact of untreatable infection can be. But even before then, we were thinking that if we don't address this properly, we could be dealing with economic impact on a similar basis to the 2008 crisis. But this is a dent in the global economy and productivity that will continue. There will be no rapid bounce back. And there's been quite a lot of discussion on what the impact of COVID will be on antimicrobial resistance. And I think at the moment we're still not sure. Certainly, it has helped that the world is now much more aware of the importance of preventing infection and the risks of not doing it. And there has been a lot less burden of infection. We haven't seen a flu season this year. But against this, we know there has been widespread use of antibiotics inappropriately in the treatment of COVID, a massive disruption of programs, and a shift of political focus and thinking. Now, in order to address this, in 2015, a global action plan was developed. All member states of WHO came together and endorsed this plan, which is really a straightforward public health plan, focusing on the importance of developing awareness, strengthening our knowledge and surveillance, optimizing use, reducing infection, and developing new products. And this plan was endorsed by the Food and Agriculture Organization and by the Organization of Animal Health. And countries, all member states of WHO, committed to also develop their national action plans to take this forward. What is encouraging is that by January this year, 143 countries had their plans, and many countries are now developing their second or third plans. What is much more worrying is that many countries lack the capacity and resources to actually implement their plans. So going to scale still remains a major challenge. But just to unpack some of the things of what the importance of infection and what we in WHO and with our colleagues in the Food and Agriculture and Organization of Animal Health are doing, there is a big focus on the prevention of infection. We have hand hygiene week this week. We really encourage just the basics of hand hygiene, which can make such a difference. But immunization is also very important, because if we prevent infections, then people don't need the antibiotics.
Проводим вакцинацию, то антибиотики их использовали просто вот нападает необходимо.
No, just basic water, sanitation and hygiene provision in communities and health workers, in health facilities, is incredibly important. And 40% of facilities in Africa lack these basic resources. So this is a major feature of the plan in human health. It's also a major feature in animal health. Have strength and wash to prevent the development and transmission of infection. When we, 6 years ago, there was no global surveillance system, and we had very, very little data on what was going on in many countries in terms of the development of resistance. And the data is still patchy, and there are biases, but we now have a global surveillance system. Over 100 countries have joined, but they start to put in their data, and that will start to give a much better picture of what is going on. And we need to have better understanding, not only of where resistance is emerging, the levels of resistance, but also how much antibiotics are consumed, so that we can really manage and understand the global practice. And this data, we've been very data poor. We now to really have that understanding so we can manage the system and take it forward. And this data on resistance and consumption patterns can inform our stewardship decisions. The whole business of using antibiotics much more judiciously is extremely important. It's an important thing to balance access, because we still know that in many countries people are dying because they don't have access to effective antibiotics. So we must sustain access for those who need them, but prevent inappropriate use. As has already been discussed, the AWARE classification is a way of encouraging physicians and those involved in medicines management to use the first-line drugs, which are effective, narrow spectrum, and where the risks of resistance are much lower, so that the more specialized drugs in the reserve capacity can be used for when there is a real crisis in hospital and the last-line treatment drugs are preserved. But it's important that we use antibiotics judiciously, not only in hospitals, but also in the community and in primary care, where there is a huge amount of use and ongoing use. And we need to work with our colleagues in the veterinary sector to ensure that they too use antibiotics appropriately. We have a list of drugs, the critically important drugs, that we discourage use in antibiotics in animals, so that they can be preserved for effective human use. So we work together as a tripartite. We have now established a tripartite joint secretariat that works together to coordinate action, support the development of global governance structures, a multi-partner trust fund established to support work together at country level on these World Health agendas. And we are very delighted that Dr. Anna Popova has joined the Global Leaders Group, which was established in January this year. As you can see, this is a group of leaders, ministers, chaired by 2 prime ministers, with also scientific and private sector leaders from all sectors, from human health, from animal health, from the environment, who are coming together to drive and lead and advocate for the AMR agenda. And we will also be establishing an independent panel rather like the panel on climate change that provides global evidence on the state of the problem, of the issue, and advises on what needs to be done. That panel of experts will be established in the next year, and also a civil society and private sector. So, in summary, thank you very much for inviting us. My key messages are that AMR is a global threat and real and present threat now, but it will get very much worse if we don't prevent and really act now. And this has to be action not only in the human health sector, but in partnership with those working in animal health, in the environment, and the food sector. Thank you very much.
Thank you very much, Dr. Taylor, for your interesting report. Thank you very much. А мы продолжаем.
We move on, and I would like to present the next speaker. It will be carried out by Professor Priputnevich. The floor is yours. Well, good morning, dear colleagues. My message will be on the following topic. We will be sharing with you the information on how we prevent antibiotic resistance in maternity houses, maternity houses, how we keep under control pathogens that are most typical for such hospitals, those who lead to infections of newborns, and so on. Can I have my slides on, please? First of all, I would like to start from the fact that in recent years we see major changes in operations of maternity houses. Here you can see a number of documents adopted in Russia recently that coordinate operations of maternity houses in Russia. And we can say that one of the indicators is as follows: the reduction of newborn deaths in Russia, which is extremely significant. It should have been reduced a few times, but I should say that in 2020, the newborn death was at a very low level. And today, we have more than 1,000 institutions that provide a very high-level service. 124 of them have a status of perinatal centers. Certainly, development of perinatal development dictate command providing high-level services, and that's what we do in our institutions. And we see here what contingent of people we have to work with. We have women with various health issues, natural abortions, and so on, and a number of pathologies. Sometimes it could be even oncology. It's not an exceptional case these days. That leads to the fact that many patients of ours have been taken hormones and antibacterial agents that could lead to the born of infants with some infectious pathologies, and newborns that are born prematurely. And certainly we see here a certain level of risk and proneness to infections, especially while providing medical services. If we look at the incidence and number of deaths among newborns, we see that the share of a high share of deaths are accounted to perinatal centers, as well as a distribution of newborns that were dead alive, but that were born alive, but dead shortly afterwards. So this data we got from the statistics of the Ministry of Health. And therefore, today, there has been adopted a program of audits. We do not like this word because it has little to do with the work of our hospitals. But anyways, we are talking about regular checks performed by a number of specialists, including epidemiologists and bacteriologists and other experts. And one of the assessments they have to carry out is evaluation of epidemic safety and prevention of infecting, as well as pharmacovigilance. Well, today we do understand that in Russia there have been carried out two very important programs adopted by the government of the Russian Federation. First is the strategy of preventing antimicrobial resistance in the Russian Federation up to 2030. And today we have been developed a number of reference centers, including the Russian surveillance agency Rospotrebnadzor, and we have been carrying out a project Alexey Viktorovich has been talking about. We certainly see that significant steps are being made in order to improve this situation, and so that antibiotic resistance would be kept under permanent control. And in particular, our work, we perform our work on the weekly basis. You see that our teams of 7 to 6 people visit various Russian regions. On this slide, you see that more than 50 regions have already been visited by the representatives of our national center, Perinatal Center, and as I said, this program started 2 years ago that allowed us to conduct an analysis in order to find gaps or flaws that could be eliminated in order to improve the overall performance. And certainly we should not just discuss the problems, but we have to find solutions. First of all, we paid attention to the fact that there are differences in structures, organizational structures of various medical institutions. Even if we talk about perinatal institutions, first of all, it's a lack of personnel, lack of high qualified personnel in order to follow sanitation requirements. I'm talking about epidemiologists. Sometimes some perinatal centers do not have them at all. Bacteriologists, clinical pharmacologists that, as you see, account for 0.1% only of overall personnel that work in maternity hospitals. Without those specialists to perform appropriate control in order to reduce infections is next to impossible. Certainly, we talk about big disparities in work of different departments, for example, in surgical department or maternity department. And even in perinatal centers of the Russian Federation, there are a number of differences. I would not stop on details as we are limited on time, but you can find them on that slide. Nevertheless, when we talk about the pilot project, we can say that a number of actions have been made, and the analysis of the work shows that we can overcome the fear of registration infections that were detected while providing medical services, and we see that those medical organizations, hospitals that register infections, they have higher rates of infections, given that they provide objective statistics. We want to encourage all medical centers to not to be afraid, not to be scared, but provide us with objective data in order to take needed actions in future. The same goes for pregnant women. We see that the data differ greatly. If you see 0% of infection, it doesn't mean that there are no infections at all. Our expert is a pilot expert in pilot center in this project, and we do hope that at the end of by the end of the project, we will be able to show very encouraging figures. In the Russian Federation, as some infections are not still registered in medical hospitals, it is very difficult to get the clear picture, but we nevertheless are pretty optimistic. We hope that this practice will be commonplace in a very near future, even if it sounds optimistic. Another issue is that there is no plan regarding etiological structure of the infections. But one of the biggest issue is lack of microbiological laboratories in many medical hospitals, in maternity hospitals, including perinatal centers. So we talk about organizations that have intensive care units, those who take care of patients with quite complicated issues. They are certainly must establish such labs. And microbiological tests shall be done regularly. On this slide, we see the centers that have their own labs, but there is another problem. Even if medical hospital has a lab, most of them, 80% of them, use manual methodology. Certainly, perinatal medicine today requires high-tech equipment that will make it possible not just detect, not just understand the structure of pathogen, but and perform genetical tests to assess antimicrobial resistance, prevalence of those strains, and provide antimicrobial therapy that is needed. So microbiology today shouldn't be only fast, but should be of high quality. Our center certainly studies etiological structure of infections that are typical for maternity houses. And certainly we know our main enemies are microbiological agents that lead to those infections. In the recent years, we see the reduction of sensitivity to common microorganisms, or simple, we are talking about E. coli, Staphylococcus, Streptococcus of the big group. And I'm talking about outpatient departments sometimes, not about in the inpatient department where antimicrobial resistance could be much higher. So we see that antimicrobial resistance is getting higher and higher. We see the reduction of sensitivity to Streptococcus agalacti, which is the microorganism number 1 in leading to in-womb infections. And today we are still the country that does not provide proper control of this infection, and even there have been certain criminal cases initiated against doctors due to the neglect of this infection. It is believed that this agent is sensitive to penicillin agents, the first antibiotics that are given to newborns in terms of infection complications. But in order to prevent those infections, we have to take some measures to eradicate them. And there are a number of countries that successfully control this infection before a newborn is before baby is born. They provide a screening of pregnant women and provide antibiotic prophylactic measures in order to eliminate it during pregnancy. If we talk about prevention, we shouldn't use penicillin agents, as there are a number of contradictions. So sometimes we have to use antibiotics that, as of 27, that show high resilience, that have high resilience with. Next pathogen is Gardnerella vaginalis, one of the more biggest problems for us that lead to vaginosis and so on. We would say there is metronidazole that helps to treat this pathogen, but having conducted a number of trials, not with a large number of patients, but nevertheless, we see that metronidazole shows 100% resistance, and that has been described in our practice. So when we prescribe to pregnant women metronidazole, we probably should ask ourselves, why do we do it? Next infections are Staphylococcus infections. This is a very old problem, and starting from perinatal centers and other departments, hospital departments, we know that they could lead to outbreaks in departments where which face this problem on a common basis. For neonatology, there is one more problem. Apart from golden staphylococcus, in the group of prematurely born children, the number one pathogen is CoNC. So, in other words, we fight with two pathogens that have to be monitored. If we talk today about operations of maternity houses, we should understand that CoNC and golden staphylococcus lead to a number of serious problems, and they show a very high resistance to beta-lactam agents and even medicines that have been used as a result agents. So, in other words, we see a very high resistance. And this height and such prevalence is seen in a number of number of medicines. So for a number of years, together with Vladimir Sutorenko and his lab, we have been conducting a monitoring when we track the resistance of CoNC, and we detected that today we have two clones of Staphylococcus communis, and Sergei Vladimirovich performed an investigation. We have an idea, Sarah, how they were brought to our hospital. Our children, after all, they get a very intensive treatment after cardiosurgeries, and certainly we should do our best in order to eradicate those pathogens indoors in the hospital. And to conclude my presentation, I would like to say the following. We know the main mechanism of resistance of microorganisms, and we know that there are a number of testing kits that allow to detect genes of resistance, but why shall we do regular continuous monitoring? Monitoring, the word itself says it shall be continuous. Why shall we introduce new methodologies to detect resistance? So that we have adequate testing kits that could be used in the clinical practice. And today we have a question. Shall we include Gencifir into such panels? So, dear colleagues, we do understand that this work is extremely important. I hope it will be carried out in future. As I said, we are a reference center in neonatology. We hope we are going to cooperate in future with Rospotrebnadzor, and we will get success in future. Thank you very much, Tatiana Valerievna. Thank you for your report. Thanks for your fantastic report. Unfortunately, we are very limited in time, so now I would like to give a floor to a group of authors from Pirogov Medical Center, and I would like to pass the floor to Daria Kamyshova. Good afternoon, dear colleagues. Today I introduced the Pirogov Medical Center in our vision of monitoring antibiotic resistance. So it's a natural feature of microorganisms that is given to them by nature, but as we know, antibiotics have been part of our everyday life. They have been used in medicine, in agriculture, and so on. And we know that resistance is a very big problem, and negligence of this problem by medical directors and lack of adequate measures in order to prevent antibiotic resistance lead to the fact that the problem and infections that get out of control. And we do understand that antibiotic resistance leads to lots of labor costs, and this threat the lives of our patients. Besides, it's a very expensive problem. In order to evaluate the burden of antibiotic resistance, we performed a trial in our medical center that specializes on treatment of patients with antibiotic resistance. So we had two groups of patients. One had genes of resistance to antibiotics, and the second group didn't have it. And as it turned out, the presence of antibiotic resistance really influences the two clinical outcomes. We see that median of hospital admissions among patients with antibiotic resistance is 7 days compared to 2 days in the second group. And as for mortality rate, it's twice as high as in patients that do not have resistance. Certainly, it affects badly the economic costs of treatment. An average cost of one treatment is 4 times as high compared with no antibiotic resistance. If we talk about why did we pay attention to this problem in 2011, look at the level of antibiotic resistance. We see that level of ESBL 80-90, carbamide 26%, and that was 10 years ago. If we talk about non-enzyme bacteria, so to the measure of antibiotics, it was 60 to 100%. And as for prevalence of SK bacteremia, it was 101 cases. So certainly we took measures in order to establish a control strategy. We developed, we established a team and started to introduce additional measures on the annual basis in order to provide successful antimicrobial therapy. Recently, we have been dealing with the detection of antibiotic resistance. Every year, we try to adjust protocol of antimicrobial protocol. It's one-time monitoring. We analyze data, compare them with the last year data, and into 2020, we got a decree on antibiotic resistance. According to this decree, we have to conduct a regular monitoring for departments where we have where we have
членов команды SCAT, and the roles were allocated according to the reaction to this situation. So it gives us an understanding and an opportunity to respond as fast as possible to these problems. Antimicrobial stewardship team in our inpatient facility. This is the scheme that includes protocols, educational events, the system of control and safety, as well as internal audit. All of that allows us to prevent the abuse of antibiotics and increase the level of infection safety in the inpatient facility. And, for example, speaking about the dynamics of consumption in the inpatient facility, we can see that since 2013, the consumption of antibiotics per 100 bed days in the inpatient facility has decreased twice, and the annual growth in the number of patients since 2013 has more than doubled. And given that in the inpatient facility, we understand that zero level of safety cannot be achieved. So it's important to understand what agent is the basis of infection. That's why the decrease of escape group in our facility allows us to select the best empirical antimicrobial therapy. And the structure of escape agents in the total structure of our agents actually has decreased 2 times since 2013. The protocol of empirical antimicrobial therapy is a key instrument to control antimicrobial resistance in the inpatient facility, but it requires a lot of work. Its work is very subtle, so the version of protocol that appeared earlier, actually the basis of risk stratification, was based on a situation when a patient stayed in ICU for more than 3 days, and we had type 3B. But thanks to monitoring of antimicrobial resistance, we saw the excessive use of carbapenem that are frequently used as empirical therapy. We have amended our risk stratification because the level of infection control in our inpatient facility allows us to shift these terms. So our patients can be colonized by polyresistant agents after a later time. So we have analyzed whether it was actually logical to do so. And you can see that in the group of carbapenem-resistant Klebsiella and Pseudomonas aeruginosa, all of them are related to group 3B in 100% of cases, and as a result, we saw the decrease of consumption of carbapenem of group 2 by the factor of 2. We think that the most important indicator of resistance decrease, as I said, in 2011, non-fermenting agents had the level of resistance of 60 to 100%, and in 2019, the level of non-resistance of Pseudomonas aeruginosa was 45%. And we understand that this is a high level of lack of resistance. But speaking about non-fermenting microorganisms, of course, the system of infection safety and control is very important. That's why in Pyragov Center we pay a lot of attention to screening of polyresistant agents and fast response of infection control, effective disinfection of surfaces, hand hygiene to prevent further dissemination. And you can see that the share of non-fermenting microorganisms trained in the general structure is not a problem for us. So the share of Acinetobacter has decreased. It is 0.7%, and Pseudomonas aeruginosa is 4.2%. An important component of every control strategy of all complex measures is educating personnel. So we think that a lot of attention should be paid to it. It's important. So it's important not only to train doctors, but also to train the team of antimicrobial stewardship, because we need continuous increase of knowledge. These are the results of our training programs. We have analyzed the terms of de-escalation. You know that in RCU, de-escalation is quite complicated because the patients are in severe conditions and it's not always possible. In 2017, the timeframes of de-escalation were 3.75 days, and in January 2020 it was 1.88 days. And of course, a major role here was played by the development of bacteriological lab that can give us data on microbiological structure in a faster manner, and we can respond faster in terms of de-escalation. So actually I asked to shrink my presentation, but okay, I can speak about it as well. This is an anti-example, COVID-19. So Kulikov Center in 2020 had a hospital and it actually worked. So I can actually skip the slides probably. Here the main goal was to show that when we face a problem that we cannot really control, that we're not aware of, then still it happens that, well, we cannot respond as fast as we can do regarding our current problems. So in COVID-19, we had such a trend as resistance, especially non-fermenting microorganisms, because COVID-19 actually made us face a lot of problems. We lacked staff, for example, and some other issues. And this is my last slide. I wanted to thank you for your attention, and I wanted to thank the team of Kulikov Center for their everyday work, thanks to which we can show these brilliant results. Thanks a lot, Daria Andreevna, for your interesting presentation. So we've had some round of applause here, although we're not numerous in this room. And now we'd like to give the floor to Professor Sergey Vladimirovich Sidorenko. You can see him right now. We're very glad to see you, Sergey Vladimirovich. For a long time, we have discussed the issue of virulence and resistance. There are some hypotheses that resistance is accompanied by increased virulence, and there is an opposite standpoint that states that resistance is always about adding some additional genetic information, and it results in decreased adaptivity of microbe and decrease of virulence. But actually, there is no silver bullet here, no universal solution, and today I would like to speak about one microbe and the way of virulence and resistance, whether they go together or not. I will speak about Klebsiella pneumonia. Well, actually, this book was developed quite a long time ago. It was described in 19th century, and lethality was high, up to 70%. First of all, this was pneumonia. So sometimes they felt that it was pneumococcus, and actually localizations were different. Abscess of soft tissues, liver, kidneys, and others. And during that time, people frequently noticed that colonies of Klebsiella, some of them have hypermucoid phenotype, and I will actually show you the way it looks like. Actually, today, Klebsiella, well, after molecular methods appeared, actually now we know a complex of Klebsiella pneumonia that includes various species, Polycora, Africana, Quasi-Vericona, and it's actually impossible to differentiate them with classical methods. We need to use molecular methods for it. And they have never said that all Klebsiellas for some time were not reviewed. And over the last 10 years, we have had classical Klebsiellas that actually resulted in healthcare-associated infections. They could be localized in various places. And actually their virulence was quite low. We cannot say that they were completely not virulent, but still. So previous speaker mentioned that as well. The most unpleasant thing regarding Klebsiella is that they generated multiple resistance very fast. And today there are about 5 to 7 plasmids, and frequently they develop pan resistance and hypervirulent lines. Well, about in the 80s, in southeastern Egypt, they started registering diseases in healthy people without comorbidities. However, they had quite typical localizations, such as endophthalitis, meningitis, brain abscess, and liver abscess. And what is important here? Actually, it was sensitive to antibiotics, and if the diagnostics and treatment were timely, it was possible to stop it. When they checked this Klebsiella in mice, they showed quite high virulence, less than 10 to the point of -3 COE. That is very low. They can be localized on chromosomes and plasmids, and plasmids are huge, 200,000 pairs of bases, and today we do not have a consensus. We cannot clearly state what signs, what genes are 100% necessary for virulence appearance. Sergey Vladimirovich, actually, you are not changing your slides. You know it? Could you please switch on the slides, because now we can see only one slide, I guess the first one. Can you see my slides now? Not yet. We do not see it. We do not see you. What about now? Can you see it now? No. I request organizers to help us. Yes, now I can see it. Okay, thank you. So, I mentioned that there are two lines here, hypervirulent and sensitive to antibiotics, low virulent but resistant to antibiotics. So what happened recently? Well, actually this information will be described a bit later. What is the difference between hypervirulent and classical type? In hypervirulent type, the capsule is much thicker. And another important point is that apart from siderophores that are typical for normal Klebsiella, there are two more siderophores, pseudophilin ivermectin. Normally, this is a capsule type K1, K2. But what is important for practice? In 2018, the first publication appeared in China stating that there are strains of Klebsiella that showed hypervirulence and multiple resistance. This is the first work from China that describes this hypervirulent Klebsiella. This is the way it looks like in a plate. So you can see that it's quite long. This is a positive strain test. And this Klebsiella had KBP. They showed virulence on positive neutrophil test. They gave 100% lethality on bee moth larvae. This is a surrogate test, not to kill the mice, we decided to use the larvae. And they had virulent plasmid. So this is the first publication of 2018, and since that time, this has been a very relevant problem globally. And what's going on now? These are the first works. Here there are two genetic lines of Klebsiella, 395 and 147 types. And this is the top line. It's actually marked gray. They showed lethality of mice 10 to the point of 2. They had maximum possible set of virulence determinates, and they had beta-lactamase, DM1 type. And at that time, we were not able to identify plasmids. I mean, the genetic determinates where they were localized and what are the possible ways of resistance formation when hypervirulent isolates of plasmids receive genes of resistance, and also when multiple resistance isolates of plasmids get virulence genes, and the worst case is when hybrid plasmids are formed, when virulent plasmids have resistance genes, or when resistance plasmids have virulence genes. And what happens most frequently, according to the global experience, we can see this process when virulent plasmids get resistance genes. And this is continuation of our work. Recently, we have found a number of isolates. So at first, we had only 390 and 147. Now we have 390, 874, and others. These are various capsule serotypes. Serotype 2, and serotype 2 is most typical. And most of them have genes, BLA genes, and in one isolate we found a new carbopenemase that has not been described before. This is NDM29. They showed high index of virulence and resistance. What did we do next? At the early stage, we could conduct full genome sequencing on Illumina platform. It is characterized by high accuracy and short reads, but after this full genome sequencing, we cannot divide plasmid from chromosomes, so we added full genome sequencing on Oxford Nanopore platform. This is one sequencer, and Oxford Nanopore, this is another device that is just a bit larger than a computer stick. And here we were able to get very long reads, but quite a high error rate, and combining these two approaches, we were able to get long reads and high frequency. This is hybrid assembly that allows us to get annular plasmids with chromosomes. And today we understand that Russian plasmids, you can see it here actually, well, they originate from Europe and Great Britain. This is British virulent plasmid, and this is its relative in Russia. And what does it have? It has this small piece. And here, beta-lactamase NDM type gene is. These are two variants of plasmids. So it means that on some stage, we're not sure whether it was in Russia, in Great Britain, or in a different country. Actually, this gene was acquired by hypervirulent plasmid. And let's look at the plasmids that circulate in Russia and globally. And the closest relative of our plasmid, you can see it here. So the gray color between two lines means that they are identical. So actually, we cannot see two identical plasmids. So somewhere we see very intensive genetic processes, and our plasmids are very similar to the plasmids from Great Britain and Czech Republic. So today we see a very unpleasant picture, new phenotype appearance. It will be difficult to treat it because of resistance, and it will cause high lethality due to hypervirulence. And of course, this is one of the most serious threats to the healthcare system. The first stage to prevent dissemination of such virulent and multiple resistant Klebsiella is convergence of hypervirulence. Actually, the first stage is to find VIR and MDR Klebsiella. So we have this effect, which is supposed that hypervirulence is there, and clinicians should pay special attention to abscess, meningitis, and endophthalmitis. So if on early stage we are not able to detect and monitor and somehow prevent further dissemination of such hypervirulent Klebsiella, then potentially we can experience not only post-genome era, but also hypervirulent era. So, I call on cooperation. Microbiologists should detect these isolates at an early stage. And of course, we have antimicrobial stewardship program, and this is one of the goals of such program, because this antimicrobial stewardship program allows us to build a constructive dialogue between the clinic and the laboratory. And the sooner we start detecting these isolates in our inpatient facilities, the more chances we have to avoid that. Thank you, Sergey Vladimirovich, for your interesting presentation. And our final presentation, Ildar Renatovich, who represents Gabrichevsky Institute, will be presenting. The floor is yours.
Да? По 30, не важно. Мне кажется, все уже.
Еще 10 минут.
Да? Ну, ладно. So, dear colleagues, I would like to introduce you the report of strategy of FAGA-mediated control as a guarantee of safety of food products. Innovation use of bacteriophages included two main components: bacteriophage-mediated control and measures to prevent bacterial contaminations of animals and processing food, and phage-mediated processing in order to prolong shelf life of meat and other food products before they are packaged in semi-product foods. As for microbiological safety in 21st century, it's still a very relevant problem. New ways to store products in vacuum packaging, minimum processing, longer transportation, and lack to follow hygiene requirements by the personnel lead to a higher risk of contaminating products with salmonella, Campylobacter, Listeria, and other pathogens. Application of antibiotics in food industry does not help to eradicate the problem and lead to the emergence of new pathogens, a new strains of pathogen agents that are resistant to antibiotics. In America, Canada, and the UAE countries, the increase of cases of outbreaks that are transferred with food led to the development of new segments of products based on bacteriophages. Agency of Environment Safety, starting from 2005, started to register such products as pesticides. FDA in the US, starting from 2006, registers phage-containing products as supplements. And as a case for phage-mediated control, I would like to introduce the biopesticide, including bacteriophage agriphage that has a cocktail of virulent phages that is active against bacteria that affect tomatoes, pepper, and so on. Efficacy of using bacteriophages on pepper compared to chemical pesticides is shown on slides. In 2007, Amniolytics and Delanka got approval of FDA and Ministry of Agriculture based on bacteriophage against a number of bacteria for treating animals before going to slaughter. To illustrate the efficacy of phage-mediated products, we can have a look at FDA technological supplement that uses a cocktail list shield. It includes 6 various bacteriophages that more than 170 strains are sensitive to, and it allows to produce ready-to-use meat and poultry. This supplement is used before packaging meat at processing plants and poultry factories. as well as doing semi-ready products by using spray treatment. FDA recognized Listex supplement as a part of the GRAS list, which means that they are safe and can be used in the food industry. In the food industry, it can be also used in cheese production, and later on in 2007, it was recognized and approved to be used for other food products. In 2011, Intralytics introduced a cocktail containing 3 virulent bacteriophage that are part of mere viruses. They were divided from sea water, and they're active to 111 strains of E. coli, 76 strains of a number of E. coli bacteria, and could be used during processing of raw meat. Also showed a very high efficacy during 96 hours for 95%, which was equal to 95%. In the same year, Holland Medical Expert Advice Agency approved to use bacteriophage in order to eradicate salmonella on the site of the one largest poultry production sites. And later on, it was introduced in order to approved by FDA a SalmoFresh cocktail that's specifically active against high pathogen salmonella strains. Within the research program approved by the Russian surveillance agency Rospotrebnadzor, we have developed a number of products in order to prolong life shelf of a number of food products, such as ground meat, dairy products, and so on. Here you can see stages of development of phage containing products, starting from dilution of those products and registration with the surveillance agency. Here you can see the first technological supplement with ACD7. It is sensitive to it is sensitive to E. coli and other cell groups. As for phage-mediated products, it made it possible to irradiate E. coli in ground meat within 24 hours. One of the strongest features is ability to resize a number of a wide group of pathogens. Together with a reference lab of the European Union, we have divided colifax in order to resize the toxin strains, E. coli. 44 out of 51 strains have been listed in Moscow, in the Moscow region. Therefore, it was proved that our phage are effective against Escherichia coli that have been circulated in the European Union. To use them in dairy industry, we have developed a supplement with the use of bacteriophage ESD together with bacteriophage stack against Staphylococcus. The processing together with the said bacteriophages make it possible to reduce the amount of pathogens by 99% within a few hours. The third product of decontamination is technical supplement based on 3 bacteriophages that are active against Salmonella enteriditis. On this table, you can see the design of the trial to eliminate Salmonella from poultry semi-ready products. Previously checked parts of poultry have been contaminated with E. coli in the amount shown on the slide. The pieces were treated with bacteriophage with a different type, and 48 hours later, we saw the full elimination of salmonella in both series of the trial, while the level of salmonella in control samples was very high. In order to disseminate the bacteria in swine, in beef and swine meat, we used bacteriophages against which that activates against a number of salmonella strains. It was treated. We treated the meat with bacteriophages, and it showed a very high efficacy. Microbiological monitoring was performed during the whole shelf life of the product. Samples from control and trial groups were kept at the temperature of 2 to 4 degrees. According to the technical protocol of the customs control, it was E. coli was identified in the samples that were not treated with bacteriophages. On the second days in this sample treated with bacteriophages, there was no E. coli, while the control samples contained an increased amount of E. coli. Developing decontamination agents for chilled fish, we found out that a number of bacteria that are present on the surface of the skin can lead to infections in fish, but and also lead to a shorter shelf life, and with improper processing, they could lead to toxic infection among humans. The additional factor to detect microbials on the surface is disinfection of the production sites and the equipment that could lead to a higher risk of microbial biofilms on the surfaces that are concocted with the product. Physical methods of equipment leading in the fish industry, they lead to a worse nutritious value of the products and lead to the production of new strains of pathogens that are resistant to antibiotics. Due to the said information, we wanted to create a decontamination agent that used polyvalent cocktail of bacteriophages that would be active to strains that lead to the waste of fish products and human infections. We divided and selected prospective strains of bacteriophages, and together with one fish farm, during the processing of fish, of trout, we treated the fish with the bacteriophages. So it was processed by putting into the water that contained bacteriophages. Control of bacterial criteria of the samples showed it's possible to prolong the shelf life by 4 days with preserving ecological safety and nutritious value of the product. Despite the progress in food safety, infections are still high risk, especially to people with low immune system. Phage-mediated control could be an additional effective tool to prevent pathogens into the food products. This method is especially has a very high potential especially for producers of food industry. Thank you very much for your attention. Well, thank you very much, Eldar Renatovich. Well, we have run out of time. We have no time for any discussion or questions. I would like to thank you all for your very informative and fantastic reports. Thank you very much for your attention, dear audience, and hope to see you soon.